Hello everybody, welcome to this video. In this video, we will see a question based on projection of lines. It's a special type of question in which one end of the line is on HP and the other end is on VP. The question is, one end of a line EF of length 90 mm is on HP and 25 mm in front of VP, while the other end is on VP and 40 mm above HP. Draw the projection and find its apparent length and inclinations. Also locate the traces. Now since one end is on HP and 25 mm in front of VP, so draw a reference line like this. Since one end is on HP, the front view of that point will be on the reference line itself. So from here, mark that point E dash, front view on the reference line itself. This is E dash. Now since it is 25 mm in front of VP, so from here mark 25 mm downwards, because in top view in front will be downwards. So 25 mm in front will be 25 mm downwards. So from E dash, mark 25 mm downwards, name that point as E. Draw the locus to that point, also do the dimensions. This is E dash and this is E. Now since it is given that other end is on VP and 40 mm above HP, since the point is on VP, the top view of that point will be on the reference line itself, whereas since it is 40 mm above reference line, the front view of above HP, the front view will be above 40 mm above reference line. So from here, keep some distance like this, and from here you mark a point here and at 40 mm above, then draw a reference line, draw the locus like this, and also do the dimension like this. Now since it is given the line length is 90 mm, from E dash we want to draw 90 mm, we want to cut 90 mm like this to this 40 mm above line. Name that point as F1 dash, and also do the dimension 90 mm like this. Now it's given that the true length is 90 mm. So from E, one end is in front. So from in front, you want to cut an arc to the on VP line. So this is VP line, or this is the top view of the point F. Okay, the top view of the point F will be on this reference line. So from here, from E we want to mark 90 mm like this. Cut 90 mm to this reference line. Name that point as F2, because this is true length. These two are true lengths. So we want to name it as F1 dash and F2. Now from F1 dash, draw a vertical line like this to the locus of E and name that point as F1. Now E as center and E F1 as radius. Draw an arc like this to meet the locus of F2. This is name that point as F. From here, E as center and EF1 as radius. Draw an arc like this to meet the locus of F2. That is F. Name that point as F. Connect E and F. Similarly, we want to draw a vertical line from F2 to the locus of E dash. So since F2 and E dash are on the same line, we cannot draw that line. So now E dash as center and E dash F2 as radius. Draw an arc like this to the locus of F1 dash. Connect that E dash to that point, that is F dash. This is F dash, E dash F dash line, and this is EF line. On observation, you can see that F dash and F are parallel, are vertical lines. The line drawn through F dash and F are vertical, and which is parallel to the line drawn through E dash and E. Now on measurement, you can get E dash F dash, which is the front view length, is equal to 86 mm. EF is the top view length, which is equal to 81 mm. Similarly, the actual inclination of the line with respect to horizontal plane is 26 degrees, and with respect to vertical plane is this angle, this is 16 degrees. Also apparent angles of the front view is 28 degrees and apparent angle of the top view is 18 degrees. Thank you very much for listening to this video. Thank you.